Hello everybody, this is our next video notes. So go ahead and put your name at the top of the paper please, and the date. We are going to move into identifying angles. So to identify angles, first we need to talk about how to name angles. So naming angles, there are two different ways to name angles. If we look at this example right here, you can name angles by their vertex. So you can name angles by their vertex. Their vertex is where the two rays meet to form the angle. So here this angle would be called angle B. And this little sideways V is our angle symbol. Or you can name angles by the points at the end of the ray, the point at the vertex, and the other point at the end of the ray. So this example would be angle A, B, C. So what you want to make sure if you use this method is that this middle letter is always the point at the vertex. So looking at an example of that, over here we have a few different angles. So if I want to name angle number 1 right here, angle number 1, I notice the vertex is at X, but this whole angle of 1, X is referring to the whole big angle. So I can't name it by angle X, but I can use these 3 points. So I'm going to name it angle W, X, Y. And then same thing for angle number 2, I can't just name it by the whole vertex. So I'm going to use those 3 points, Y, X, Z. But if I wanted to refer to this whole angle, so angle 1 plus angle 2, I could call that angle X, name it by its vertex. Or I could name it W, X, Z. So I want to use W and Z and not Y because we're talking about the whole angle. Alright, so now that we know how to name angles, let's look at a couple different types of angles. So complementary angles. Complementary angles are angles that add up to 90 degrees. So the angles are going to form a right angle. So if you look at this example right here, find the missing angle LJH. LJH. I can see I have this nice little right angle symbol here, and it's telling me that LJK is 40 degrees. So if this whole thing must be 90, but this one little angle is 40, then I can do 90 minus 40 to find that the missing angle is 50 degrees. So this angle and this angle are what we call complementary angles because they add up to 90 degrees. Similarly, we have supplementary angles. So supplementary angles add up to 180 degrees. So supplementary angles are going to form a line. Just like supplementary angles, if we have two angles that do form a line, we call those a linear pair. So two angles that form a line, so they are supplementary. They are supplementary. So if you slide your paper over a little bit, you'll see we have an example of a linear pair right here. We have two supplementary angles. And we want to find this missing angle, MNQ. MNQ. So I know that this whole angle here needs to add up to 180 degrees. We have that this angle is 110 degrees. So what I'm going to do is subtract 110 from 180, and I find that my missing angle is 70 degrees. So 70 degrees and 110 degrees are a linear pair. They are supplementary. So if I look at these two angles that I have here, I notice that they are lying on a line, so that is a linear pair. So they are not complementary, but they are supplementary. So to find what x is, if I want to find the value of x, I know that all together these angles need to equal 180 degrees. So I just need to add them together. So I'm going to write 75 plus 2x minus 5. You want to make sure you keep that sign correct, so we're adding this whole angle. So then I just do a little bit of algebra here to solve for x. So 75 minus 5 gives me 70 plus 2x equals 180. Subtract 70 from each side. I end up with 2x equals 110. If you grab your calculator, divide each side by 2, you get 55. So our angle here is not 55, x is 55. If I wanted to find what this angle is, I would need to plug x in for x right here. So 2 times 55 minus 5. That's going to give me 110 minus 5 gives me 105. So 105 is the measure of this angle. And last but not least, if you want to check your work, we know these need to add up to 180. So 75 degrees plus 105 degrees, put that in your calculator to check, does in fact equal 180 degrees. So those are supplementary and they form a linear pair. Now we're going to talk about some angle relationships. So we have this nice diagram right here. We've got 3 different lines and a bunch of different angles. So first I want to point out that this line right here is called the transversal. So this is super important for the next couple days in geometry class. We're going to see a lot of different transversals, and you might have some diagrams with more than one transversal. So it's important to see which one is the transversal with all of our angles lying on it. So there's always going to be 2 lines cutting through, and the transversal cuts through those 2 lines, and that's how we form all those angles. So you might want to grab a couple different colored highlighters or markers or pens for this. So we are going to be looking at what these different pairs are called. So alternate interior angles, alternate interior. If we look at our diagram here, interior is going to be talking about the inside between these 2 lines. And the word alternate means opposite. So I'm going to color these angles. They're alternate interior. So 2 and 8 are alternate interior. 2 and 8. We have another example of 3 and 5. Alright, alternate exterior, if you haven't guessed it already, alternate exterior are on opposite sides, but exterior is going to be talking about the outsides here. So alternate exterior could be angle 4 and angle 6. So they are on the exterior sides and they are alternate, they are opposite. So angle 4 and angle 6. Another example would be angle 1 and angle 7. Consecutive interior, you might see it called same side interior. Those are going to be the inside, but on the same side here. So if you grab a different colored marker, oops, sorry. I'm going to color angle 2 and angle 5 because we want the same side. So angle 2 and angle 5. Another example would be our other same side interior, angle 3 and angle 8. Alright, we only have 2 more, so corresponding are going to be talking about the position the angle is in around the transversal. So if I look at angle 1 right here, angle 1, the corresponding position to it over here is going to be angle 5. So angle 1 and angle 5 are corresponding. If we look at some other examples, there's a bunch of corresponding ones. Angle 2 seems to be in the same position as angle 6. I move around the transversal here. Angle 7 is in the same spot as angle 3. And last but not least, angle 8 and angle 4 are in the same positions around the transversal. And then last but not least, vertical angles are talking about angles that are opposite each other. So an example could be angle 1 and angle 3. They are opposite. Or angle 6 and angle 8. And there are a few different examples of vertical angles in here. All right, great job, guys. Go ahead and make sure you've got all of this written down and bring this to class tomorrow. And we will finish the rest of the examples with our table partners. Have a good day.